Okay, welcome back. This is Chapter 14. This is the last chapter in the book. Okay, so as always, we're going to start with the learning objectives. And this one is a kind of a weird one. This is on managerial issues, and so they have lots of information about design and stuff. So, high-level overview of the design process. The important concerns about network management, because these things just don't run themselves. The process by which computer network standards are developed. Boy, is that a wild one. And the role of government and the legal process in computing in general. Okay. So just to start with, let's just talk about design in the big picture. At home, you go out to electronics supply place and you go buy you a wireless router combo, and it comes with a firewall and a DHCP and DNS and a switch and a wireless, and basically you don't have to do hardly anything to design your network at home. I mean, other than taking it out of the cardboard box and plugging it into the wall and hooking up the cables. That's about it. So outside of a home environment, the designs make an awful lot of difference. You could make some very horrible mistakes and the performance of your network would be really, really bad. So bottom line is, and this is not rocket surgery, that, a good design makes for a good network. Okay, whatever. So, like I said, this chapter is going to be broken up. The first thing we're going to talk about is network design, which is kind of weird. So on page 343, they talk about the design process. And I will tell you that their definition is not bad. It talks about meets the needs of current and future customers with the minimal amount of cost. There's a phrase that we used to use in engineering school, and it went something like this. Practically anyone can build a bridge, but only an engineer can build a bridge with the least amount of material. All right, and let that kind of sink in a minute. The idea is that if it's done right, you get extra things. You get just as good a bridge, but it costs you a hell of a lot less. Well, that's what they're talking about here. Practically anyone could throw some wires together, but if you want it to perform well and cost least, then you really need somebody who's done this before. You need to have an honest-to-God real network design. So the first step in any design, and literally we're talking any design, you could be building a bridge, a house, or a network, doesn't matter. The first step is describing the problem. What problem are you trying to solve? Because trust me, if you don't know the problem you're trying to solve, then chances are that your design is not going to solve it. Just telling you. It's sort of like that Star Trek character in Star Trek Voyager. Please state the nature of the medical emergency. It was never tell me what's wrong. It's to the point. Please describe what it is you're trying to do. And after you've described that, then I can come up with some decent ideas. So, the whole point of requirements analysis is to answer a single question. And that question is, what must this thing do? That's it. What must this thing do? That's the number one question in requirements analysis. So, typically you would have to, since let's assume that you're a third-party person that's called in to do this design. You don't have anything to do with the company. You've never seen them before in your entire life. So you're going to have to spend some time talking to people, interviewing people and asking them, what is it you need? What do you want this network to do? And unfortunately, there may be a technology gap between you and the people you're talking to. So you're going to have to kind of be the translator, like, they're speaking one language and you're speaking another, and you have to kind of translate between the two. So one of the things is, can you categorize the users? Can you say, well, you guys are heavy network users over here, and you guys are light network users over here. You might be able to draw it down just a wee bit. Some sort of a classification of users or perhaps applications. This application over here is kind of wimpy, doesn't have any effect on the network, but this application over here is a real pig, and he consumes all the network resources all the time. So that'd be good. You also need to know their physical locations. How physically far apart are they? Because there's an awful lot of things. For example, if they're more than 100 meters away, then probably just a single, category 5 category 6 cable is probably not going to work. So you need to know geographically where these guys are. Are they all in the same building? Are they in separate buildings? How far apart are the buildings? You really need a map. When you do this little interview, you need to be talking with people about, throughput and all the rest of that stuff. But then you have to have a map showing, well, here's building A and here's building B and it's 500 feet apart, and here's building C and it's 300 feet. You need all that information. And then, of course, you don't ever want to design something that only meets the current requirements. That would be bad. If I'm building a bridge that only met the current requirements, it would probably be a single lane bridge. But no, I'm thinking, well, in the future, there's probably going to be a heck of a lot more cars. Maybe we ought to go ahead and make this a 2-lane bridge, right? So, same thing here. The idea is, okay, they're currently not using voice over IP, and they're currently not doing an awful lot of real-time video like Skype kind of things. They're not doing an awful lot of that, so I'm not going to build a network that can do that. If they want that, they can come back and ask for more. Is that the way it works? No, you need to go to them and say, here's your current needs, here's where I think you're going to be, we're going to build it to this standard. It just kind of makes sense. Okay. All right. The first thing after you've gathered all the requirements, you can start the design process. And the first design part is kind of simple. It's called a logical design. And a logical design is not really, it's not a shopping list, okay? It's not a list of things to go buy. It's like a diagram of here's what these things, here's how many switches I need, and here's where they're physically located in this logical thing, not where they're going to be physically located on a 19-inch rack. We're talking about just here's how many, and here's where they get placed in the order. It's very simple. It's just like a Visio diagram of where things are. Okay, so the point of the logical, remember, if you go back to the questions, the requirements analysis was, what the heck do you want this thing to do? The question that gets answered in the logical design is, how the heck am I going to do that? Okay, that's the question that gets answered here. Here's how I plan on meeting the requirements. You say you've got 5 people over here in this building that's a mile away. My solution is put in a fiber optic cable between here and here, and have a switch here, and Cat 5 cables going over. In other words, I'm telling you how it is I'm going to solve the problem. You told me what the requirements are, and now I'm coming back and saying, here's how we're going to do what it is you asked me to do. Not down in the weeds, not Model X costs $400, not that, but just you're going to need some fiber, you're going to need this, and you're going to need that. It's the logical view of the network. Okay, so typically most people do the logical design like on Visio. It's just kind of simple. So there's a little diagram here that basically shows, this is one way you could start with a design. So here's a building. I guess it's a building. It's kind of hard to tell. Here's a building, and they have a bunch of executive office and admin, and their data center, and some IT folks, and some editing rooms. And so you've kind of sketched out what the requirements are. Okay, well, there's 4 corporate desktops, and so therefore, and again, thinking ahead, there's 4 people in the executive offices. Okay, 4 computers. So am I going to run only 4 wires? Well, that would be dumb. The rule of thumb is about essentially the ITU, International Telephone Union thing, recommend 3 cables, 2 network cables and a phone cable to every workstation, because they kind of anticipate that something's going to happen in the future. So these guys are saying 4 corporate desktop with 8 ports and 100 meg each. And here they have, 15 corporate desktops and a network printer, but they're going to round it off to 20. Okay, makes sense? Their data center now, the data center is going to be bigger, right? It's going to be a lot faster. Instead of having 100 meg, we're probably going to go, the bigger stuff like gig E kind of thing. So a couple of gig E, and then a couple of them that are at the 10s. So this is higher. The IT folks, 4 desktops, 8 ports, editing room, 20 plus a network printer, rounded off to 30. Okay, so now I've kind of got my requirements. I went around and I asked them, here's what you need, and you're writing all this down, and you've got the distances. And so the next part would be, what am I going to do? Well, okay, well, I'm going to have a firewall, and I'm going to have a this, and I'm going to have, this is the logical diagram of how you're going to do what you said you're going to do. So, for example, that this switch right here only needs to handle about 8. This switch here was 30, if I remember correctly, or maybe this one was 20, and this one was a little different, and so you've now come back and said, I am going to solve your problem by these parts. And again, this is not a shopping list. This is not model numbers and all the rest of that stuff. This is just the logical view. Okay. So, listing of all the hosts, the servers, all the locations, perhaps even the networking scheme that they have, if they already have. Now, clearly, if you're starting from scratch, you probably have to come up with your own. But anyway, do I want to have all these on separate subnets? Yeah. So this is the 1 subnet. This is the 2, and they got a 4 and a 6 and a 3. So here's all the different subnets. So you've worked out in your head. Because remember, if you say this is going to be a subnet over here, well, that kind of implies there's going to be a router somewhere. If it's not going to be a subnet, I could probably just do it with a plain old switch. So this is kind of one of the important things. If I say that there's going to be 5 subnets, that means there's going to be a router there with 5 ports on it. Okay, cool. Later, we're going to get to let me get back to this one. Later, we're going to get to the honest-to-God physical design. And the physical design is going to be, the shopping list. It's going to be, okay, thank you for your diagram. Now, what do I need to buy? Because, for example, it very well could be that this little router doodad and this guy may physically be all in one box from one vendor. It is possible. So this is to show the parts, not necessarily the number of boxes, because you're probably not going to have that many boxes when it comes to buy. So the question that gets answered when you get to the physical design is, what do I need to buy? If you can answer that question. So first question is, what the heck is this thing supposed to do? Second question is, how the heck am I going to do that? And third question is, what do I need to buy to pull that off? So buying it. So here's where you actually, pick the technology. I go in there and say, I think I'm going to use category 6 cable. I think I'm going to use this particular type of cabling or this particular type of switch. And, you actually go through and start picking the networking technology. So all the switching components, you need to be very explicit about, if I need 5 or so of these switches, well then, by God, I need to, put that on the list and buy 5 of these guys. So switches, routers, firewalls, the whole shebang. When you get a little bigger than this is obviously a small environment. When you get a little bigger than this, there's a philosophy out there, and it's called the layered concept. And here's how it works. Now, clearly we're talking about big thing like, university campus, or maybe university campuses, plural, all connected together. So this organization, they have an engineering switch router doodad, and it connects a couple of organizations. Then they have a health department guy, and then they have an admin, and then they have a business school. And in the middle is what they call the core layer. And the core layer's sole responsibility is to reliably put, I'll tell you, let's start on the outside. This is called the access layer. This is where all the devices, the PCs, the servers, the printers are all installed at this outside ring. So the access layer is typically where you're familiar. This is where you hook up your PC to the LAN. The distribution layer is all about getting information to this layer. And then you have the core in the middle, which the core's responsibility is only just getting information to and from the other distributions. Okay, this is a good place to stop for the 15-minute mark. We'll pick this thing up again in just a few.